Hello, in this video we will be explaining the main steering concepts and parts overview. The first steering concept we will cover is open center non-reaction. Open center means that all the oil is going through the steering unit to the tank, even if we are not steering. We can tell that this is an example of open center, as, while in neutral, we can follow the line from the pump to the tank. This is an example of non-reaction because the left and right sides of the cylinder are not connected. So if we turn the steering wheel and let go, the steered wheels will remain in a fixed position. The next steering concept we will cover is open center reaction. This is an example of reaction steering, as the two sides of the cylinder are connected. This means that if we stop steering and have a force in the cylinder will move, causing the steering wheel to turn until the steered wheels are back in a straight alignment. It is important to note that the reaction effect must be designed into the axle of the machine. In this animation, the fluid can be seen passing through the unit and to the tank. Therefore, both animations are open center. If we steer, the fluid passes into the cylinder, moving the stroke to the side. When we stop steering, the animation on the left will not move, while the animation on the right will return to its neutral position by allowing a steady amount of oil to come back through the steering unit and connect from L to R or R to L. Load sense uses a priority valve to control the flow coming from the pump. When there is enough pressure in the control flow line, CF, the priority valve will shift to the right, diverting flow to the excess flow line, EF. Load sense static uses a static priority valve, so there will be no flow from the priority valve going to the LS line. The oil will enter the priority valve and exit to the control flow or excess flow line. Load sense dynamic uses a dynamic priority valve, which uses an orifice to create a constant flow in the LS line. Now when oil enters the priority valve, some will be going through the orifice to the LS line, while the rest of the oil will flow through the control flow or excess flow lines. This constant flow provides multiple benefits. The first is to avoid thermal shock. Thermal shock can happen in a cold environment when there is no flow to the steering unit. If we haven't steered for some time, the steering unit will become cold. When we steer, the warm oil meets the cold steering unit. This can cause different components to expand at different rates, which could cause them to seize. This constant flow prevents the steering unit from getting cold, and therefore prevents thermal shock. Another benefit of this flow is that it makes the steering response quicker. Load sensing static and dynamic can both be reaction or non-reaction in OSPE. In the load sense static animation, we can see that when we are not steering, there is no flow going to the unit. In the load sense dynamic animation, we can see that there is still some flow going to the unit, even when we are not steering. The different parts of a traditional steering unit are shown in the exploded view of an OSPE. The shaft of the steering wheel will mount to the top end of the spool. As the driver turns the wheel, the spool will rotate. Inside the housing, the neutral position spring provides a steering torque when the steering wheel is turned, and sets the spool sleeve set back to neutral when the steering wheel is released. The crosspin links the sleeve to the gear wheel via the cardan shaft. This means that when the gear wheel rotates, the sleeve will rotate at the same time. When the shaft is rotated relative to the sleeve, the ports of the sleeve direct flow through the gear set and out of the steering cylinder. The cardan shaft is linked to the sleeve at the top via the crosspin and is linked to the gear wheel of the gear set at the bottom. The ports of the distributor plate direct flow from the housing to and from the 7 chambers of the gear set. The gear set meters the flow through the steering unit in proportion to the rotation of the steering wheel. The flow is led from the pump into each chamber of the gear set and out again to the cylinder port of the direction in which the steering wheel is turned. The gear wheel rotates in sync with the sleeve because of the cardan shaft and the crosspin. That is everything for this video. Thank you for watching.